In this lecture video, let's take a look at how we can evaluate logarithm expression. So here are the general properties, okay? Some of the properties for logarithm and natural log. So remember, natural log is actually a logarithm. It's just using base e. All right. So the first one saying log with any base of 1 or a natural log with the base e, right, of 1 is always equal to 0. So log of any base of 1 equal to 0. So it's natural log of 1. All right. Log with any base of b of itself is always equal to 1. Okay. So kind of explain this number 2 here just in a minute, okay? So number 2, number 3, number 4 is actually all based off the same kind of concept, all right? So if I'm taking a log with the base b of itself, it's always equal to 1, all right? I'm telling you the reason here real quick, okay? Conversion between exponential equations and log equations. So basically, since we know that the logarithm is an inverse of exponential, if I'm starting off with a logarithm with any kind of base a or b of x, what we can do is set it equal to y. All right. And then to convert into exponential, all I'm going to do is bring my base to the other side of the equal sign. Okay. Remember, base is an a. So when we convert into exponential, that a is going to be the base. So that means the y, whatever that variable is, we bump it up to an exponent. So we just set, so to convert from logarithm to exponential, we set whatever this number is or whatever this variable is, x stays on the left side. We just bring the base to the other side and bump the y, whatever variable we set, to an exponent. Okay, that's how we convert from logarithm to exponential. So let me show you this real quick. I'm going to do a couple examples and I'm going to come back to explaining number 2, 3, and 4 here. So here's a logarithm expression we want to convert into exponential so we can actually figure out what the answer is. So I'm going to go ahead and set my logarithm equal to y. Convert into exponential simply means I'm going to bring my base 3 to the other side. So that means my 81 stays on the left side, which is equal to my base 3, now raising to the y power. Okay, we bump this variable up to the exponent. So now this is actually an exponential equation. So what we want to do, like before, is try to make the base the same. So 81 is actually 3 to the third power, because 81 is 9 times 9, which each 9 is 3 times 3. So 81 is 3 to the fourth power, which is equal to 3 to the y power. So once we convert into exponential, then we're going to make the base the same so we can actually solve for the variable. So y is equal to 4. So what that means is the original problem, log with the base 3 of 81 is actually equal to 4. All right. So it's kind of hard to understand looking at the answer from the logarithm perspective, but it does kind of make more sense when I'm looking at it from the exponential perspective. That's the reason why a lot of students don't quite understanding logarithm, because you can't look at the answer from the logarithm perspective and trying to figure out why the answer is the way they are. We actually need to look at our answer in terms of exponential perspective. Okay, therefore, then the answer makes a little bit more sense. All right, let's try this one. Okay, on the one on the right, I'm going to again set my logarithm expression equal to a y, convert into exponential equation by simply moving the base to the other side. So that will give me fifth root of 64 is equal to 4 to the y power. So I need to make the base the same. Okay, so that means I need to try to figure out a way to make 64 into a base 4. So if you actually think about it though, 64 is actually 4 to the third power. 4 to the third power is actually 64. All right, so this is actually a radical. So for my base to come outside, what I can do is convert my radical into a fraction exponent. So remember during the review, we said that the denominator is the roots. So since I have fifth roots, that means my denominator is 5. The numerator is what your base is raising to, that power. So this is actually 4 to the 3 over 5 power. So fifth root of 64 can be rewritten as 4 to the 3 over 5 power is equal to 4 to the y. So now when the base are the same, we can set the exponent equal. Therefore, my answer is going to be 3 over 5. So log with the base 4 of fifth root of 64 is 3/5. Okay, the answer is 3/5. All right, this one right here, set it equal to y. So bring my base over, I get 1 over 16. Okay, it's equal to 2 to the y power. So I can make 16 into a base 2 by saying this is 1 over 2 to the fourth power. Right, 2 to the fourth power is 16. All right, so since the other side is actually base 2, this base is actually in denominator, so we got to flip it back to the other side. Therefore, my base 2 now is to the -4 power. Okay, remember the negative exponent where we got to flip the base to the other side of the fraction, make the exponent positive. So we're just doing it in reverse. So that will be 2 to the -4 power equal to 2 to the y. So once the base are the same, we can set, and the base are equal, we can set the exponent equal to each other. There you go. The answer is -4. All right. Log with the base 1 over 4 equal to 16. All right. Set this expression equal to y. Bring the base to the other side. So I get 16 equal to 1 over 4 to the y power. All right. So I'm going to make my 16 into a base 4, which is 4 squared. All right. Since my base 4 is in denominator, I'm going to flip it back to the top. So I get 4 to the -1 power. 4 to the -1 power, whole thing still raising to the y power. By the power rule, I can multiply. So that will give me base 4 to the -y power. So if I since the base are the same and the base are equal, I can set my exponent equal to each other. Therefore, y is equal to -2. All right, so this whole entire expression's answer is going to be -2. All right, let's try this one right here. Set it equal to y. Move the base over to the other side. So my 8 is equal to 64 to the y power. So it's easier to make base 64 into a base 8 because that will be 8 squared. But since I'm still raising to the y power on the outside, that will be 8 to the 2y power. All right, on the left side, this 8 is actually to the first power. So set the exponent equal to each other. My answer, y is equal to 1 over 2. All right. I'm going to do the natural log here last. So let me do this one real quick. Let's do what's inside the parenthesis here. Log with a base 16 of 4. Set it equal to y. Move my 16 over. That's 4 equal to 16 to the y power. So I'm going to make my 16 into a base 4. So 16 can be rewritten as 4 squared, still to the y power. So by the power rule, For exponents, this is 4 to the 2y power equal to 4 to the first, right? This 4 is representing 4 to the first. So now set the exponent equal to each other, but y is equal to 1/2. So what's inside this parenthesis is going to be 1/2. So what I get here now is log with the base 2 of 1/2. Set it equal to y again. So we just basically continue to convert them into exponential. So this is going to be 1/2 equal to 2 to the y power. All right, this time I'm going to bring this base 2 to the top. So that's 2 to the -1 equal to y, that equal to 2 to the y. So y is equal to -1. All right, so this whole entire answer here is going to equal to -1. All right, now I'm going to show you how to do this particular problem in 2 different ways, okay? First thing first, I'm going to change my natural log to a logarithm with a base e of 1/8 root of e to the 7. Then I'm going to set this equal to y. So I can show you that I can bring the base to the other side. So that means now I get 1/8 root of e to the 7 is equal to e to the y. So just like the previous problem, I'm going to convert this 1/8 root, this radical, into fraction exponent. So that will be e to the denominator is the root. So that will be 7/8 equal to e to the y power. So if I set that now, when I set the exponent equal, this is going to be 7/8. All right. So that's the answer. That being said, we can basically look at it this way. All right. And this will explain the property of that up here, 2, 3, and 4. Basically, what's happening here, because this is actually true, then what we can do here originally is by saying, go ahead and convert the radical into fraction exponent. So this is natural log of e to the 7/8 power, which also means the natural log part also means log with a base e of e to the 7/8. So what that means is when you take a logarithm of your base e of the same thing, if the base is the same as what you are of, then they can automatically cancel each other out. Therefore, the only thing left is just 7/8. So, previous step, when I have a natural log and the e, they can automatically cancel out. That's why the answer is just 7/8. So, back up here. This b, this log with a base b, log with a base b of b, that b is actually to the first power. So, when I'm taking a logarithm of my base b of the same thing, then they automatically cancels out. That's why the answer is just 1. Same thing with natural log, because this natural log of e means e to the first. So they canceled out. That's why the answer is also 1. So that's why number 3 makes sense. Number 3 is saying if you take a logarithm with a base b of itself, then they automatically cancel. So whatever you have on the exponent is going to be your answer. Okay. So same thing here with number 4. When I take a base b, when I have a base b of logarithm with the same base of x, the base b and the logarithm with the same base as what you're of here can kind of cancel each other out. That's why the answer is going to just be x. Okay. So that's the reason why if you ever heard teacher says natural log and e cancels out, because this is actually true. When you convert them into an exponential, okay, when you convert natural into an exponential, the final answer is it's going to be what's on the exponent. Therefore, the natural log and the e kind of cancel. You can look at them as they kind of cancel each other out since they're inverse to each other. That's why the final answer is going to be 7/8. All right. Now, this problem, okay, remember my calculator, when I press the word log, that's base 10. This problem is using base 5. So what do I do to actually put this in the calculator? Well, I have to convert this expression into using the into the basis I can use. So I'm going to use the change logarithm base formula to help me. So my base b is 5, my m is 8. So this is going to be 6 times log with the base a. The a can be 10 or e. So that will be log with the base 10 of my m divided by log with my base 10 of my b, which is 5. All right, so let's put it in the calculator. I'm going to put the logarithm in the parenthesis just to be in case, okay? 6 times parenthesis log, that's only one term, of 8, close parenthesis, divided by log of 5. 4 decimal place, 7.7522. All right, that would be my answer. Okay, so just a quick video on how we can evaluate logarithm expression by simply converting our logarithm into an exponential equation. And we're actually solving our logarithm from the exponential perspective. All right, that will conclude this video. Thank you for watching.